Hey guys, thanks for checking out the video on fasteners. So the first thing I want to talk about is basically the big defining characteristics between bolts and screws. Bolts and screws are the two primary types of fasteners that you're going to see. We're going to look at a couple other types, but these are probably the two most readily available and most readily used. We see that the bolt is very heavy of body and the screw is very light of body. So the function isn't necessarily what determines whether it's a bolt or a screw. That head shape doesn't really determine it. We can actually have bolts like the lag bolt, which is functionally like a screw with that large aggressive thread pattern, the pointed tip, and it operates very much like a screw, but since it is heavy of body, it is a bolt. And likewise, we have a screw, very small of body, but functionally it's like a bolt, has a nut and washers and all that other fun stuff. So it operates like a bolt despite the fact it being a screw. So remember that the heaviness of body is what determines whether it's a screw or a bolt. So let's talk about bolts real quick and what goes along with them. The most common type of bolt we have is the hex bolt. You see they come in a large variety of lengths and diameters. Also, they come in different grades, and the grade is an important thing to consider when you're purchasing hardware or when you're implementing the bolts, because the different grades will have different performance characteristics, and you can determine those different grades by looking at the head of the bolt. So if we see on this bolt here, we have those 3 marks on the head, and this determines that it's a grade 5. There's the other common grades out there are 2, which is unmarked. So 2, 5, 8, and 9. Primarily what we're going to be working with is grade 5 in here. Typically your grade 2 is kind of recognized as almost disposable or shipping hardware, something you're not going to spend very much money on. So to really use this though, because this can't really be used in exclusivity, you are going to have to join this with a couple other pieces of hardware. But before we move on to that, let's talk about a couple other types of bolts. Now, we may want a different presentation. So the way that our bolt sits in the wood, we want it to look differently, or sits into our material. So that's why we have a bolt like this. This is a flat head bolt. So we can use our countersink bit to make room for that head, and then we can sink that down. So this is even with the top of our material. So we get a nice clean presentation out of this bolt. It still has that the same heavy body, the same tight thread pattern that you would use a nut on, but this is going to give us a different presentation in the wood. Also, we have a carriage bolt. So our carriage bolt is really determined by this big head, and then if you notice on the bottom here where it has that square piece, and that square piece allows us to use our material almost like another tool. For example, you can, like for this carriage bolt here, this is the hole is drilled to the sides of the shoulders, and then it was hammered in. So here the wood material is actually holding on to that square part of the head, and then the fasteners go on the other side. Now the primary advantage of that is now this is a one-tool fastener. I don't need to have a wrench on each side to tighten this system down. I only need a wrench on one side. So that single tool fastener is one of the advantages of the carriage bolt. And also it's tamper resistant, because there's no good way to get a tool on this to begin to take this apart. So as long as you're on this side of that bolt, then it's really difficult to take this system apart. Now, in other instances, we're not going to want to use any tools at all, and this is why we have things like this. So this is a wing bolt, and that goes with the wing nut. Now the primary advantage of the wing nut and the wing bolt is it's a toolless fastener. It goes on hand tight. The primary disadvantage of this fastening system is it goes on hand tight. You're not going to be able to get it too much tighter than this because it's specifically designed for a toolless application. Now we kind of brushed on this, but the lag bolt, functionally it's like a screw. So you are going to have to pre-drill because of that heavy body. You want to pre-drill slightly smaller than the body of this bolt, and then you'll drive it with a hex head. Now the hex head isn't particular to the lag bolt. There's a number of heads, be they hooks or eyes or even different thread patterns. Like you can have these two lag points pointing in opposite directions, or a threaded kind of bolt pattern on the other side. Now if you notice on this head indicates that it's a grade 2. And the overwhelming majority of your lag bolts are going to be grade 2, simply because they're designed to go into wood, and that wood is going to have a much lower failure point than your hardware. It's still zinc coated, so we're still going to have that rust protection of the zinc, or galvanized depending on what you purchase. But we don't necessarily need the performance characteristics that we would see at ever grade 5 or grade 8 or grade 9. So that's just a kind of quick overview of our bolts. So now we're going to look at what goes with bolts. So when we looked at our wing bolt, we had our wing nut, but generally speaking, when you're using your hex bolt, you're going to use your hex nut. Hex nut is called this because it is hexagonally shaped, it is tapped, which means that it's threaded on the inside, and these are just going to screw together. Now, because they are hex on both sides, then it does give us the ability to put 2 tools on this. So this is going to be a 2-tool fastener. And we see that this hex head does not have a very large surface area. And we can increase that surface area. Generally speaking, we're going to use a flat washer. And this is what our flat washer looks like. So the flat washer just simply goes over there. We can see now that operationally, that this flat washer almost doubles the size of the surface contact we have. And when you're using this, you are going to want washers on both sides of your material. Washers are really inexpensive. Not only do they increase the surface area, but they also protect your materials from damage that your hardware may cause. So, so using those washers is very advantageous. So just for this demonstration, we're just going to use my hand as our material here, and then we're going to just put the bolt right on top, or as I was, the nut on the bolt, and so therefore we have this larger surface area on our nut as well. Now, if this piece of hardware was used where there'd be a lot of vibration or a lot of movement, that movement or vibration could eventually work this nut off. So we have another piece of hardware that we can use to protect this system in that application. And that piece of hardware is this. This is called the split lock washer. So we do see that it does have a split, and it does have that locking features caused by that split. So we'll set this up right on top of our washer, between our washer and our nut. And then as we begin to tighten our nut, these 2 arms of our split lock washer, one's going to bite into the washer, one's going to bite into the nut, and that's going to increase the friction coefficient needed to break down the system. Likewise, there's going to be spring tension here, also increasing the friction coefficient needed to break down the system and give you greater holding power here. Now, if you don't have enough room in your bolt for that split lock washer, we can couple this up with a thread locking fluid, thread lock, or grip tight, whatever you want to call it, and then it's going to be chemically is going to do the same thing that our split lock washer does. And the split lock washers, like a lot of our other pieces of hardware, come in a wide variety of sizes. And then another type of lock washer we have is something like this. So this is called the tooth lock washer. So it locks in place just like the split lock does, but instead of just having that one split with those 2 points of contact, it has a large number of contacts on the inside. Primarily, there are two types of split of the tooth lock washer. This one's an internal tooth lock because all the teeth are pointing in. When that diameter starts to get very small, it'll flip, and then the smooth part will be on the inside and the teeth will be on the outside, and that's called an external tooth lock washer. Functionally, it's the same as our split lock washers. It just does the job a little bit differently. And we do see flat washers in a wide variety of sizes to correspond with the size of our bolt. The other type of washer we have is called the fender washer. Now, these fender washers we see are much larger in diameter than our flat washer, but the size of the fastener that goes in them is much smaller. So we would see a much smaller piece of hardware that would be used with this fender washer. So, but we have the larger surface area, so we're going to be able to use this on things with larger surface areas but lower weight. They're called fender washers because they're originally used on fenders of cars, which are made out of sheet metal, very large but relatively lightweight. So that's the primary difference between the fender washer and the flat washer. These 2 particular fender washers have the same exterior diameter, but we can also see very closely that it takes 2 different fasteners. So one of these is designed to carry slightly more weight than the other. So that's it for our washers. and our nuts. So now if we start to look at some of the other fastening systems, primarily when we're looking at wood, we're going to move into our screws. So screws are pretty ubiquitous. We really don't see them being used outside of framing. You're almost going to exclusively use screws just because the holding power is so much greater, and with battery operated drills and corded drills, we're not doing that by hand, so it's not as labor intensive as it has been in the past. So the application of a screw is much longer than the application of a nail. However, it does get a much better hold, especially if there's a lot of movement involved. But we'll talk about these nails later. So when you're choosing your screw, you basically need to decide where is this screw being used, because the overwhelming majority of screws are going to be bugle headed. So this bugle head gives us that holding power. Since the head has a larger surface area, we're going to get some downward tension when this is fastened all the way down to the material, and then we'll have that flat presentation of this head. Now, flat heads and the bugle heads are almost used synonymously. It's a good rule of thumb, a way to think about it is flat heads are going to be bolts and bugle heads are going to be screws. That's an easy way to think about it, and maybe a line of distinction you can draw. So we see that this screw doesn't really have any sort of coating on it, doesn't have any sort of like water protection. So when you're choosing a screw like this, this is an interior screw. So you would use this maybe on cabinetry or furniture or something that would be away from water. You won't want to use this like in your bathroom or your kitchen, just because those moist environments would eventually rust and compromise this piece of hardware. So on the opposite end of that spectrum is something like this. This is an exterior screw, also called a deck screw. You see that it is coated in an epoxy, which is going to give us a large amount of water resistance. So this is obviously going to be used outside, so in those very, very wet environments. And this is going to last 10, 20, 30 years in that wet environment before it begins to rust, and chances are your wood's going to rot before your screw rusts. So if you're working outside, it's better to spend a little bit extra money and get a piece of hardware that's really designated for that. Now the next type of screw, these are really common. When you go to Lowe's or Home Depot, you're going to see rows upon rows of your your drywall screws. The drywall screws come in two basic varieties. We have our coarse thread, which has a very loose thread pattern, and the shoulders are pretty wide and thick. And then we have our fine thread. So we see those threads aren't as thick. We see that they are not quite as broad. So whether it's coarse thread or coarse thread or fine thread has nothing to do with the length, because we see that this very long screw has very fine threads, and then we see this short screw that has coarse threads. So primarily how you choose which one you're going to use is really based on your material. If you're going into new material or relatively new material that's not going to be overly dry, then your coarse thread is going to be just fine. If it's an older piece of wood, something that's very, very dry, has a very low relative humidity, an aggressive thread pattern might cause that to crack or split. So going with that fine thread, since it's kind of spreading that load that you're putting on there from the helical screw, it's spreading that load over more points of contact, so it should be less stressful on the wood. So it's coated in a material called black oxide, which acts as a water protectant. Since these are drywall screws, it is anticipated that they will be exposed to some moisture. So when you hang your piece of drywall, you're going to cover up all those screws with drywall mud when that has water in it. So that water is going to come in contact with this hardware. So that the black oxide coating is going to give us some rust protection in the early stages of this piece of hardware. It could withstand being outside, just not nearly as long as the exterior screw, and can be used interchangeably with that interior screw. So those are our wood screws. Now when we take a look at our wood nails, now there's a ton of different types of nails out there. I only have two because these are the two we're primarily going to use. There's ring shank and hard cut and button cap and all kinds of different ones. The ones that we're going to be talking about is your basic wire nail. It's called a wire nail because it's literally manufactured out of a piece of wire. And then one machine will come and cut it off, and Next machine will grab it, the power hammer will hit it and smash that head. Sometimes the heads will be a little off center, but that's just part of that process. So this is just your basic wire nail. And then the next type of nail is your finishing nail. You see that head is much smaller on that finishing nail. And the reason for that is we can use this finishing nail to have a much cleaner presentation. So we can hammer this down to very close to the surface of our material. And then we can take another nail or a tool called a punch and finish hammering this in, so this can actually be even with the surface or slightly below the surface to really hide the fact that this fastener is there. The caution when you use the finishing nail, especially when you sink it so low, is if you put it in the wrong place, it's very difficult to get this out without damaging material. So use this with caution, and really it's a finishing nail. You should be very, very far along in your process before these come out of the box. So now we're going to transition to talk about metal. So primarily when we're talking about working with metal, we see a wide variety of head shapes because we want different properties from our fasteners. We want different attributes. So the first type of kind of metal screw that we're going to talk about is the machine screw. So we do see that very, very tight thread pattern. Then we have the machine nut that goes along with it. So functionally it's very much like a bolt, but because it is light of body, it is a screw. This particular head shape is a pan head. We will see pan heads over and over again as we talk about these fasteners. It's probably one of the more common head shapes that we see when we're talking about hardware that typically goes with metal. And then along with the machine screw and the machine nut, we'd also have our machine washer. So functionally it's like a flat washer. It's just referred to as a machine washer since it goes with our machine screw, machine nut. We also have on hand machine locking split lock washers. Now not all machine screws are going to have that pan head. Both of these are round heads, so we see it has a slightly different presentation than that pan head. Now the thing that I wanted to point out is despite both of these having the exact same head shape, they take two different fasteners. So it's important to notice which fastener you need for your hardware as you start working. But to use your machine screw, there's a couple different processes involved. Either going to have to drill all the way through your material and then back it up with the rest of that fastening system, or you're going to have to do a process called tapping. And tapping is adding threads to the inside of a hole like you would see on a nut. So the tapping process allows you to turn your material into its own nut. So if you were to use this machine screw, you're going to have to drill the hole, you're going to have to tap the hole, then you're going to have to drive the screw. So we have three different processes that you're going to use when you're looking at your machine screws. Well, different pieces of hardware allow us to do different things. For example, we have what are called self-tapping metal screws. And these self-tapping metal screws allow us to pull one of those processes away. So we have our pan head self-tapping metal screw. And if you look down here at the point, the shoulders start very, very small and become increasingly aggressive. So they become wider and thicker. So this piece of hardware is actually going to cut that tapping as you drive it. So you'll still have to drill the hole the size of the body of the screw, but it will tap itself. And these self-tapping screws come in a bunch of different head shapes. So this one is actually called a washer head. So instead of adding your machine size flat washer to this, it's actually integrated into the head by the manufacturer. And this particular fastener uses what's called a T-star or Torx. It's 6-pointed, so it is slightly different than the Phillips that you see pretty ubiquitously. Now the next one, this is called the oval head. Now it looks an awful lot like our flathead or our bugle head, but you may be able to notice that the top of this is slightly bowed compared to the head of our bugle head or our flathead. The reason for this is since you are going to be tapping into your material, this extra bulge gives you the opportunity to apply more torque to this before it strips out. The good thing about working with metals, once you get everything in place, you can get your file or your grinder and grind everything smooth and hide the presentation of that. So the next step in if you want to call it hardware laziness, where you're trying to take processes out, is our self-drilling, self-tapping metal screws. So if you recall from your machine screw, you're going to have to drill it, you're going to have to tap it, you're going to have to drive it. Now with our self-tapping screw, we just have to drill and drive, and this, we really just have to drive. So the tip of this screw does have that drill bit shape to it, and then the threads are self-tapping, so we see they start very small, become increasingly aggressive until they reach their maximum size. Now this is pan head and square drive, but we have a couple different other head shapes. So we have another pan head, but this one is Phillips drive as opposed to square drive. Now our other two kind of unusual ones, I shouldn't say unusual, but just not pan head. This one is called a button head. We see it's very low profile, large surface area, so it's shaped like a button. So that's where it gets its name. And the next one, you see it has a relatively small surface area. Doesn't have a very, very large head. This is called a cheese head because it's shaped like a block of cheese. But there's a lot of different head shapes. So feel free to just do a Google image search for screw head shapes, because there's dozens out there. These are just kind of the common ones, or the ones that you're going to come across when you're here in the Fab Lab. So if you don't need the tension that is provided by the helical screw that we see in bolts and screws, if you just kind of need something to deal with vibration or deal with a lot of movement, because these guys don't like movement or vibration, that's where we get into the pins. So pins serve the function of dealing with rotational force pretty well, and really dealing with linear force very well. So if you think of the trailer hitch on your car, it really is only dealing with pushing and pulling. So it's a very static type of load that's going on that particular piece of hardware. So that's why the hitch pin, you see that so ubiquitously, because you don't need a bolt, you don't need that tension that a bolt will provide. You just need something to hold things together. So the most common type of bolt, or most common type of pin, is the clevis pin. You see the clevis pin kind of it's very similar to that button head, shallow profile, and then it has this hole in the end, and this hole in the end is for another pin. So this pin is actually going to be doing the work, but the other pin on the end is going to be holding it in place. So you may hear someone say retaining pin. Well, all pins retain, so technically every pin is a retaining pin. But this hairpin, now some people prefer cotter pins. I prefer hairpins because you can use them over and over again until they break. And cotter pins you only get 1 or 2 uses out of. So that's why we have hairpins in here. But that hairpin goes through that hole in the clevis pin and then snaps to this first position. Now you want there to be some play in it. So we see that there's some movement in this hairpin. And that's really what we want, because this allows the system to deal with vibration. Is when there's tension in this system, that vibration becomes a problem. So even just by giving this a 90 degrees and now this system is tight, now I have the opportunity to actually vibrate this system loose. So having a little bit of play in that system is really helpful, and that's really what we're looking for in our pin system, because we can shake this all day long and nothing's going to happen to this. And likewise, if we have 2 pieces of material that are moving, we can see that this pin has nothing to unscrew, like a nut would eventually get worked off in that type of rotational movement. So the pin is really great for that. And you can back this up with flat washers if you wanted to protect your pin or increase the surface area of your head. That's still an option in this fastener system. So pins are a really great thing. We see a lot of pins in machinery and in agriculture. So our hairpins come in a large variety of shapes and sizes, or in large variety of sizes, both the diameter of the pin itself and the material that this will hold. So we see this hairpin actually go through something that's about 1 inch in diameter. So this is a pretty aggressive hairpin. And our clevis pins, all of our pins come in a wide variety of shapes and or diameter and lengths. So the next type of pin I want to talk about is the lynch pin. Now we can see that this color is slightly different than all the other colors. Now this is grade 8. This kind of golden color, it has a luster to it, a couple other tints in there, some reds and greens you may see when the light hits it just right. But the advantage of the lynch pin is it is self-retaining. So I'm not using like the clevis pin and the hairpin together. This pin is self-retaining, so I can drop this through, click this over, and now this pin will hold itself in place. And that's really why a lot of farmers use this, because if they're in their field and they're changing the implements on the back of their tractors, instead of carrying around 2 pieces of hardware, they can get away with 1. So sometimes you'll see the guys with a big bulge in their bib overalls, and it's usually a bunch of these guys, just because they're all over the back end of your tractor. Just something to consider when you're looking at a grade 8 piece of hardware is just because it has this color may not necessarily mean it's a grade 8. Unless you can verify, either because you purchased it and the manufacturer labeled the packaging, or like in the case of our bolts where we have these markings that determine its grade, we just have to assume it's a grade 2. So I know that this is a grade 8 because I took it out of the box, so I can rest assured knowing that this is a grade 8. If I did not know that, I would just assume it's a grade 2. So we've covered a pretty large variety of hardware. So there's tons out there. This is just a good starting point. So continuing to learn the strengths and weaknesses of these different hardwares will allow you to have the ability to determine what you need on your project, to allow you to say, I need a hex head bolt because the weaknesses in this application don't matter. And that's ultimately what you're looking for when you're choosing your hardware, is those weaknesses are not impacted by the application, and the strengths are aggrandized by your application. As always, if you have any questions, come see me, and thanks for checking out the video. Have a good day, y'all. Thanks.